In this video, for our Mock 1 review, I'm going over just the first half of the question. So just focusing on the imaginary unit. So numbers 1 through 14 is what I'm going over in this video. So with these problems in the first set, notice how we are simplifying our radical. Notice how that's negative, square root of negative 96. So I need to break this apart to positive and negative 1. Then also keep in mind we are multiplying by negative 8 at the end. So make sure to multiply by negative 8. Now also notice we have the square root of negative 1, which is I. So we also need I in our final answer. But as I break down 96 even further, I could break this down into 16 times 6 because the square root of 6 is 4. So this is 4 radical 6. But notice how I'm forgetting my I here. So I'm going to bring down I, but we do also need to multiply by negative 8. So negative 8 times 4 is negative 32I radical 6. But number 2, notice how this is a perfect square, the square root of negative 36. However, it's negative, so I'm going to break it apart. So 36 times negative 1. So again, notice how we do need I in our answer. The square root of 36 is just 6, so 6I. But is this our final answer? No, because notice how we do need to take half of that. We're going to multiply by 1/2. So half of 6 is 3. That's why the answer is D, 3I. So in the last one here, we're going to be focusing on simplifying the radical of 567. With 567, when we're simplifying this radical, first off, notice how that this is a positive 567 when we find the square root of, and we're just multiplying by negative 10 at the end. So notice that there is no splitting, right? Just like how we had 1 and 2. So I just need to focus on what is the largest perfect square factor. So in this case, because this is not a negative, I know I don't need I in my answer like the 2 previous. So I'm going to go ahead and mark off A and D because they both still have I. Also make sure if you need to focus on what is the largest perfect square factor. So remember, perfect squares are like 1, 4, 9, because that's 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3 is 9, 4 times 4 is 16, 25 is 5 times 5, 36, 49, 64, right? That's 8 times 8, 9 times 9 is 81. I'll stop at 10 times 10, which is 100. So if I were to take 567 and divide that by 9, I get 63. However, I could still continue simplifying that. So here, I could use the largest perfect square factor, well, 100. But if I were to take 81, 567 divided by 81 is 7. So that means here, what is the square root of 81? That is 9. 9 radical 7. But remember, right, we are multiplying by negative 10. So multiply by negative 10, and there's your negative 90. So that's why the answer is B. So now we just have to remember with these questions, the pattern. So here I've got I to the 0, which is 1. I to the 1 is I squared is negative 1, and I cubed is negative I. So as we go through, remember our pattern. We're going to use the quarter method. I'm going to divide 204 by 4. And when you divide 204 by 4, you actually get a whole number. You get 51. So keep in mind, if we were thinking about quarters, technically the decimal then is for a whole number 0.00. So that means here, how many quarters do we have? Well, we have 0 quarters. So I to the 204 here is the same as I to the 0, right? So we're going to replace that. But keep in mind, right, we're still in the end, make sure to multiply by negative 1/2. So we're going to multiply by negative 1/2 at the end. But here we have I to the 0. What's I to the 0? 1. So that is 1 times our negative 1/2, which is just negative 1/2. Then for number 5, right, same thing. We're going to divide by 4, and also notice we're multiplying by 5 here at the end. So make sure to multiply 5 to that final answer. So when you divide that exponent by 4, you do get a large value here, but 0.75. So that means 0.75 now represents 3/4. So instead of putting here I to the 2,907, I'm now going to put I to the third power. Then go back to the pattern. What is I to the third power? Negative I. Now let's continue. Remember, right? Because we're multiplying by 5. 5 times negative I. Now notice we still have I in our answer, right? So it's not going to go away when we simplify. So I'm going to mark off C and D because they got rid of the I. But positive times a negative is a negative 5I. So that's why the answer is B. And then same thing here for the last one. Notice how you're multiplying by negative 15. So keep in mind, multiply your final answer by negative 15. So now here, when we put our exponent in our calculators, right, divide that by 4, and you get that 1,000 large value, but 0.25. So now going back here, 0.25 or 25 cents is just 1/4. So instead of putting I to the 16,441, we're now going to put I to the first power. Now go back to the pattern. What is I to the first power? I. But again, multiply that final answer by negative 15. Notice again how we still have I in our answer, so I'm going to mark off C and D. But negative 15 times I, negative 15I. So that's why the answer is A. Now question number 7, we're focusing on what values of X and Y make this true. So identify the imaginary parts, right? Identify the real. So I'll go ahead and identify the imaginary parts first, all right? So with our imaginary, what is on the left side? YI here, so positive YI. Then on the other side of our equation on the right side, what again here is our imaginary part? Just the negative I. So negative I, or remember that's understood to be negative 1. Now we are solving for Y, so we're just going to divide both sides by I. So notice how the I's cancel out, but the I's also cancel out here. So really you're just left with negative 1. So Y is equal to negative 1. So I'm going to mark off B and D. Now I'm going to look at the real. So notice how on the left side we have negative 4 is equal to negative 12x, but also plus 8. Now we're just solving a two-step. So we're solving for x. Subtract the 8 from both sides. Negative 12 is equal to negative 12x. We're still solving for x, but it's being multiplied by negative 12. So now we need to divide by negative 12. Then now notice two negatives make a positive, so positive 1. That's why the answer here is C. Then question number 8. Now this one we're looking to see what value makes A true. So looking back here, first off, notice how we're adding, so no need to focus on subtraction, but A is an imaginary number. So we just need to focus on the imaginary. So what else besides our negative AI here is also imaginary? Well, positive 5A. So here we have on the left side 5I minus 8I. Then that is equal to, what is our imaginary on the right side? 7I. So now we have to be careful because 5I minus what? Or 5 minus what would get you 7. So notice how we're growing, right? This means, because if I said this was 2, well, 5 minus 2 is only 3. So I know that doesn't work because I need 7. But if I were to say 12, 5 minus 12 is negative 7, not positive 7, right? So I know it's not B. Then let's go to C here. 5 minus negative 2. Oh, notice two negatives make a positive, and 5 plus 2 is 7. So that's why the answer here is C. Then question number 9, focus on the operation. Notice how we are subtracting, but remember when subtracting, you do need to distribute that -1 before you start combining like terms. I'm going to bring down my 17i plus 6. Now positive 18i, positive 18 is now negative 18. And negative 9i is now positive 9i. Now combine the like terms. Here the real, I have 6 minus 18. That gives me negative 12. Then combine the imaginary part. So 17i plus 9i positive 26i. That's why here the answer is B. Now notice the number 10, we can't combine our like terms yet because yes, we are adding. Notice here we have 3 times this complex number. So I'm going to bring down 5 plus 2i, our first complex number, but distribute 3 first. So 3 times 8i is 24i. And 3 times 6 is 18. Now combine the like terms. I've got 5 plus 18, 23. Then imaginary. We have 2i plus 24i is now 26i. Now number 11. Notice how there's no symbol in between, right? That means we are multiplying. So I'm just going to distribute that 4i to both terms in my binomial. So 4i times 8, 32i. Then 4i times negative 7i, that's negative 28. But I times I is I squared. Then remember, anything that has I squared is negative 1. Notice how this is a negative 28. Negative times a negative is a positive 28. So 32i plus 28, or B, 28 plus 32i. So then last here in number 11, notice how at the end here we do have subtraction. This is addition, so we're good. We have subtraction, so we need to make sure to distribute our -1. So I'm just going to write everything down. So I've got 5 plus 2i plus 3 minus 8i. Now positive 1 is now going to become -1. Negative I is now going to become positive I. Now I can combine my like terms. Well, with my 5 here, what other values are real? Positive 3 minus 1. So 5 plus 3, so 5 plus 3 minus 1, which is 8, minus 1 is 7. Then our imaginary, I have 2i minus 8i, but also plus another I, which remember is understood to be 1i. So 2i minus 8i plus that 1i. So here that's -6 plus 1, which is -5. So -5i. Then question 13. Notice again, there is no symbol in between. So with no symbol in between, that means multiply. And because we have our two binomials, I'm going to set up box method to multiply. So 3 and -5i times 2 and positive 9i. 3 times 2 is 6. 2 times -5i, -10i. 3 times 9i, 27i. 9i times -5i, -45. But I times I is I squared. So again, notice here, right in that last box, we have I squared. I squared is always -1. So -45, negative times a negative is a positive 45. So we're replacing that last box here with positive 45. Then notice we have our like terms here, the two I terms, our imaginary parts. 27 minus 10 is 17i. So now let's write out all of our final terms here and combine. So I have 6 plus 17i, but also plus that 45 here. Then I've got 6 plus 45, which is 51. So 51 plus 17i. Then the last one, notice that special case where we have our binomial, but being raised to the second power. So that's the same as 2 minus 4i times itself, 2 minus 4i. So again, with our two binomials, Let's go ahead and set up box method. So 2, negative 4i times 2 and negative 4i. 2 times 2 is 4. 2 times negative 4i, negative 8i. 2 times negative 4i again, negative 8i. Negative 4i times negative 4i, positive, but now 16 times I squared, because I times I squared. Then again here, right, we have I squared. I squared is negative 1. 16 times negative 1 is now negative 16. So we're going to replace that last value with negative 16. Then we have our like terms here, our two imaginary parts. Negative 8 plus negative 8 is not 0, right? Negative 8 plus negative 8, negative 16i. Now we write out and combine. So I have 4 here, minus 16i, but also minus 16. So notice here I've got 4 minus 16, which is negative 12. So negative 12 minus 16i. That's why the answer here is A.